Good evening, everyone. Looks like we are live and ready to go. Another live chat. This one, Wednesday, December 20th, 2023. We are starting to see the pattern changes and all of the winter cancel nonsense that we've been dealing with for the past couple of weeks are about to get slapped in the face. If you have canceled winter and decided that you do not need a snow shovel over the next couple of months, well, you, sir, you should be shoveling all the snow this year. That's all I'm going to say. We have a lot of data to look at tonight, and of course, I'm already seeing some great questions out there already, and some great stuff already showing up on YouTube and on the live chat as well, as everyone's starting to stream in. So if you're new, let me just go over this real fast, just in case. Everyone who asks questions in the premium live chat, because you are premium members, get all your questions answered, aside from, the good evening 50 times, because, there's only so many times I can say good evening. And of course, I pick the best questions on YouTube and on X. My wife, Susan, is over here helping out, as always, and we are getting ready for our winter celebration with Christmas and everything, so we are all decorated and all that good stuff. So, good evening, everyone. Wow, we already had some really technical questions, too, that are showing up. So, let's dive into the data first, and then I'm going to answer all of your questions. Now, because on X, there has been a lot of stirring the pots. All right, a little bit on my end too, to be honest with you. A little bit of my Italian nature got into this chat where I was like, yeah, dude, screw you. This is not what you said was going to be. So, here is our Pacific jet. At no time did I or anyone else say that there would be no Pacific jet. It just wouldn't be as strong and as insanely robust as what the GFS ensembles and European ensembles were trying to show. And it's not. It's there, it's present. It should be there because of where we were with the MJO state. Again, there's always a lag time between what the MJO is doing and what the atmosphere is doing. It's never a one-to-one. It's a little bit of delay, which is, again, part of the whole atmospheric system. But here we are. And again, this is what you should be experiencing. And again, this is why back in October, I put down for a white Christmas about a 1% chance on the coast, 5% maybe on the interior. And that would be if you actually had snow on the ground. So none of this is a surprise. My contention, and I think it pretty much bared out pretty well, is that this was not going to be a pattern where it would be a quote-unquote torch for months, for weeks on end. Through mid-January, we're going to shut down winter. And that we will be above normal constantly through the entire period. What I contended is that, yeah, we have a jet streak, but what we're going to have a lot of transient polar and Pacific air masses. Not a torch in terms of just constant above normal temperatures. If you don't believe me, go out the next 2 days because it's going to be a bit chilly out there. It's been chilly. So pretty much what I said was going to happen happened. Now, there are some who don't want to admit that for whatever reason, and that's fine. That's all good. Whatever floats your boat, whatever makes you go to bed at night and sleep and be comfortable. But that's where we're at right now. With that, we have a very volatile weather pattern. And the thing that I take out of this is that with everything evolving here, our subtropical jet stream remains incredibly active. Now, I got a great question on X earlier on this evening. Hey, what's with all these heavy rainstorms? And part of this is connected to the robust nature of the high amounts of precipitable water values in the atmosphere. And again, I'm going to go back to, if I'm going to study climate change and influences, I know some people don't like talking about this, but I've always said the best way to understand the influence of CO2 and warming atmosphere is to study the precipitable water values, not air point not airport temperatures. You know, your surface temperatures is too much distribution, too much error, too much human error. Precipitable water value eliminates that, and it's just pure calculations, mathematics. And with that, you can see exactly what's happening in the atmosphere. So why do we get these intense heavy rainfall events? There's more moisture in the atmosphere. Part of that also, you know, in some respects has to do with our volcanic eruption, but that is more of a stratospheric impact. But if you look at the evolution of the subtropical jet stream and the amount of warm water we have out there in the Pacific and in the Atlantic, none of this should really be a surprise. Now, with that, you have to consider something here. You have a lot of moisture in this subtropical jet stream. You add in a polar air mass or two, and you don't need an Arctic air mass. You don't need it historically cold. You don't need it well below normal, half a degree below normal. That's all. And you end up with one very impressive winter storm. You get a couple of weeks of slightly below normal conditions. A little bit of high latitude blocking. Again, nothing strong with this subtropical jet stream. And you start lining up a series of winter storms in January and February. And that has been what we have been watching. Again, when I was talking about the polar air masses in this pattern, I was not all that impressed, and I'm a little bit more impressed. So I'm a little bit more concerned on what could be coming down the pike here over the next 6 to 10 weeks. But with that, again, you don't need a lot in terms of the polar air masses with all this moisture available to create a little bit of havoc. So there we are right now with this current pattern. On the water vapor satellite picture, impressive upper level low off the California coast. Here's our subtropical jet stream, again, driving moisture in. We are protected from this with the polar jet stream and a nice ridge out here in the Atlantic, setting up pretty much a tranquil weather pattern all the way through Christmas. So if you have any travel plans, or you're asking whether or not Santa Claus is going to be okay, Santa Claus will not need Rudolph for the northern Mid-Atlantic. Probably other locations throughout the world, which is why it's always good to keep Rudolph on the sleigh. But for us, it's going to be pretty quiet. So that's good news for Christmas Eve. If you have any travel plans, you worry about Santa Claus, no worries. He's going to be fine. It's pretty impressive water vapor satellite picture at that. Why would that be? Well, these upper level lows are awfully impressive. And you know, something I'm going to come back to in a few minutes, but have you noticed that the model guidance constantly focuses the short waves further to the north, 7 to 10 days out, and then once we get closer to that 5-day period, they start to shift towards the coast, and those short waves are stronger on the coastal plain than they are over the interior? Let's look back at the last 3 storms. Each one of those storms, they have had a low pressure track initially in the Great Lakes, and then it shifted towards the coast. Now, what's been missing, obviously, is a robust polar and Arctic air mass for now. But then this gets me thinking for the end of this year. Let's put that in the back of your mind for a minute. Let's take a look at some of the observations. So here's our polar air masses getting ready to leave. Our high pressure system's getting ready to shift towards the coast. Another Pacific air mass comes in. Again, transient polar Pacific, back and forth. While that's all happening, our polar vortex here at 70 millibars is starting to show signs of disruption. Primary features up here towards the Arctic, and then we're seeing this lobe towards the Aleutian Islands. So we go up to 10 millibars. It's starting to get that stretched look again. This feature right here is awfully interesting. So we have start to see all the signals here of some mischief. And then we get the latest European ensembles data. I was talking to Dr. Cohen about this, in fact, and he had to add in some parts, some additional information for his weekly discussion that he does. Definitely check that out. He issues one for paying clients, I think, on Monday, and then an update for the public on Wednesday. Excellent, excellent discussion to go over some of the pure science involved here. And what this is showing is more and more support for a major disruption and possibly wind reversal in the stratosphere. Now, you might say, Stephen, why would I trust this 7-10 days out? And it's a fair question. It's absolutely a fair question. The model data from the European, and I'm trusting the European a little bit more only because A, it's been the most consistent. It has been B, the most reliable for years now. I mean, it's not even a contest anymore. And it has been extremely persistent with this idea for January and February for the bottom to drop out here. And it has been the first modeled guidance going back to October to suggest that, hey, there could be a weak polar vortex. I'm not even talking about a complete disruption. I'm just talking about a weak polar vortex. So it's been pretty consistent. It's been pretty good with where we're at right now. This just took a nosedive. And the reason why this really catches my eye here is that if this is reality, and this feature, which is now showing up on the GFS ensembles and the Canadian ensembles, this right here is textbook major stratospheric warming. And it just obliterates the polar vortex and sets up all of the high latitude blocking that we've been seeing in the weekly guidance, in the monthly seasonal guidance, whether it's the GFS or the European. We've been seeing this constantly. And, I mean, understandably, for a lot of you guys out there, especially, a lot of snowplow guys, I get it. For the past 4 years, we've been epically screwed over. And so, there's a lot of hesitation and a lot of concern here. I would say that this right now is the most impressive data I've seen in 4 or 5 years. I could even go back a decade. So it's pretty robust. And again, it's been consistent. If this was a one-off situation where all of a sudden the models flipped today, then I would probably be like, yeah, let's give it a couple more runs, see what happens. But this has been a consistent theme, and it's been focused constantly on January and February. There are hints that maybe we could squeeze something out in the end of December. Low confidence, but certainly something I've been bringing up just to keep an eye. And we're going to talk about that in just a moment. So we have this showing up. And again, this warming is no longer just a model projection. We're having it right now. Disruption's happening right now. The evolution of the pattern's happening right now. So we're seeing all this. Meanwhile, tropical forcing is a bit more of a conundrum. You've been hearing a lot about the strong historic El Nino. And again, if we just go by sea surface temperatures alone, sure, absolutely. But as a meteorologist, you do not just go by sea surface temperature anomalies alone. Because if you do, then you might be missing the ballpark. Now, normally, you get a strong El Nino with sea surface temperatures 2 degrees above normal, then this really wouldn't be much of a thing to cover here. Because what you would end up with is an SOI value that is tanking, like minus 15, minus 20 perpetually. Nowhere near that. So again, this could be a climate change issue. And the reason why I say that is because the very warm Pacific that we have in place is altering the thermal gradients. And this is a warning sign, again, if you are just doing textbook east-based El Nino, you're already in trouble because it's already central-based. That's not even a debate. So you have this data, And you have the MEI. Again, I've been talking about this, but I really want to bring this home because I know that there's been a lot of news stories and whatnot about the super strong El Nino, but it's not lining up with the atmospheric forcing. And look what we're seeing here. This is current. The closest we have is 1987. All of the super strong El Ninos that have been used as an example, 98, 2016, for example, are way up here. Nowhere near the forcing that we're seeing now. So with that, you cannot take those years and use that as a comparison. So I'm going to keep on drilling this home so that way, I can kind of counteract a lot of the news out there about a strong El Nino. It doesn't line up with the data. It just doesn't. Period. End of story. Much like your overpowered Pacific jet stream, it's not based on reality. So there we go. And so that brings us back to the MJO, which, according to all the data here, is taking our MJO into phase 8 and 1. This is a cold phase, and this is part of the reason why I warned, hey, we need to watch towards the end of this year, which we're going to talk about in a moment, and also early January, because there's a bit of a lag. And we're seeing a lot of data, especially for early January, for something possibly popping up here. And it won't be the last one. But I also want to discuss this signal here. Now, I am guaranteeing that somebody who really likes warm weather is going to be playing this up quite a bit. And I get it. I understand why. But there's a problem here. First of all, we got a ton of noise going on here with the guidance. But more importantly, this guidance would not work out with the major stratospheric warming event. So I wanted to pull up the warmest guidance that's out there, because I'm guaranteeing you that's what you're going to see on social media. Saying, yeah, it'll get cold and it'll warm up real fast. So let's touch on that real fast before we start getting all the memes and whatnot that's floating around there. First of all, this data would be in an event that our major stratospheric warming event doesn't happen, okay? Because then what you end up with is a stretched polar vortex that then relaxes, and then by the middle of January, you get a relaxation and a modification of your air masses, which would be very much understandable. However, if the polar vortex does tank, then you end up with this signal. This signal is a little different. Now you might be saying, Stephen, it does the same curve. But in the neutral circle. Why is that important? Well, basically, the neutral circle is basically the MJO on mute. And so the dominant signal becomes just El Nino. Again, when you're looking at El Nino and MJO, the El Nino is a large wave, large signal wave. The MJO is a little wave. Really fast moving, keeps on rotating around the earth. The El Nino is a long wave pattern. When the short wave and long wave patterns align, all heck breaks loose. When the long wave pattern dominates and the short wave pattern, the MJO, goes silent, the only thing that really stands out is El Nino. Or, if you want to flip it, La Nina. Okay, so you see how this all works. So this signal is if the polar vortex idea and the stratospheric warming event works out. The other one, the relaxation, is if it does not. So if you hear a lot of talk about that because people are scrambling because their idea of, let's say, mid-January being warm or everything being warm until mid-January, and they're finding out, but there's your old butt. That's where it's going to come from, where you have that guidance with the MJO in phases 3, 4, and 5 again by mid-January. But it also then progresses back into 5, 6, 7, and 8, going back again for February. But if that major stratospheric warming event happens, then you have to throw that out the window. because what happens is then that signal basically overwhelms everything. Much like, well, I'm not going to compare years, but let's just say that it would be a very impressive signal. So as we look at our 500 millibar pattern, we zone in on our upper level low that marches in from the west coast in the subtropical jet stream, interacts with this shortwave in the polar jet stream, which tries to pull it northward, but now instead of heading into the Great Lakes, it flings itself back towards the southeast coast. The ensemble's guidance keeps us the lowest 500 millibar heights and the lowest variance towards the southeast. And when you take a look at the 500 millibar PVA, and I brought this up to premium members the past 2 days, saying, hey, we're getting a lot of PVA towards the coast here. This may actually be closer to the coast. And so what we're seeing here is a model guidance trying to figure out all these different shortwaves and how they're interacting. A lot of chaos going on here. A lot of different shortwaves interacting. Now remember what I said about December and early January as we try to develop our high latitude blocking. This is all going to come down to, as far as any type of storm threat, as to how the shortwaves interact and play with each other. And so when I'm seeing this beforehand, here, let me pull up the 0Z guidance. It had this storm up towards the Great Lakes. I mean, no doubt that's rain, you know. Now the 12Z doesn't do that anymore. What it does now is it puts the primary low towards Long Island. That's a huge change from the Central Great Lakes, from Michigan to Long Island. That is a huge jump. And the question we have to ask is, if the model guidance is changing this much already, and we see this evolve, what are we doing with this cold pocket here? Because again, right now we're separating the polar air mass, and you got a Pacific air mass, and then you have your tropical air mass, and you have this lingering polar air mass. But if you're seeing your storm evolution shift towards the coast, and you're seeing your 500 millibar low well displaced from this, this has the potential, if we look at the ensembles, of ending up down here. And we have seen this now for 3 straight storms, where 7 to 10 days out, everything's focused towards the interior, and then we have this shift. So I would say definitely the Poconos and Catskills. We'll go for there right now. We're not going to get too aggressive. Keep an eye on this storm. And if we see this shift towards the coastal plain, right now it did the surface low. If we see this shift towards the coastal plain, and you get aggressively falling 500 millibar heights with this polar air mass associated with this 500 millibar low, this could end up being a colder solution than what's being shown right now. And it would also lead to much cooler temperatures overall. At coastal plain, I think this is very difficult to pull off. But those of you in the Poconos and Catskills, I'd watch out for this being possibly a rain to wet snow type of scenario here. And, you know, honestly, we're not that far off from it, because as you can see with this interaction, if it's closer to the coast and you're pulling in that polar air and Arctic air from Quebec, and you're seeing this interaction playing out, then certainly already the green and white mountains now are back in play. Whereas beforehand it was just a driving rainstorm. Now you're seeing this evolution, and you're seeing this low rapidly intensify as a result. So there's a lot of signals here that I would keep a very careful eye on. And just be aware, after Christmas, we have to watch this storm, especially if you're in the higher elevations. For the coastal plain, not yet. Not yet. But then, that takes me to the next question. which is once we start getting this high latitude blocking starting to form. And again, we have a very active subtropical jet stream. There's our first wave right around early January. Again, I'm not worried about the details right now, but what really stands out to me is this idea of this storm track through California, the southern tier, swinging out through the mid-Atlantic and cold air bleeding down. Again, I don't need Arctic air. I don't need it being 5 to 10 degrees below normal. You just get to freezing. Hello, storm. And this pattern is not something where we have to change a lot in the weather pattern. There isn't a lot that needs to fall into place to get us to where I think we're going to go. So again, what do we have? We have a robust polar and Arctic air mass waiting to get pushed south. We have all the signs of stratospheric warming. We have changes in the polar vortex, stretching, possibly splitting. We have an active subtropical jet stream with plenty of convection around the dateline, which would suggest East Coast cyclogenesis. We're seeing model trends where it keeps on trying to push storms towards the interior, but ends up towards the coast. Only thing now that we need is a little bit of high latitude blocking, which plays into the whole stratospheric warming event, which also lines up nicely with an El Nino with a negative QBO state. And don't get too worried about Pacific jets. Right? There we go. So that is where my thought process is in this whole pattern right now. It's pretty much has worked out exactly as I thought it would for in the winter forecast. Again, I have left it up there. I'm going to leave it up there all winter because we're going to make comparisons to see what my thoughts were back in October and where we are now. Just so that it keeps me honest and keeps everyone honest on what was forecasted and where we're at. Right now, that 1% forecast pretty much worked out as far as the White Christmas idea. And we're starting to see the storm evolution potential for the end of the month. And then January, here we go. So that's where we're at right now. Oh, this is water, by the way. So now with that, I am going to answer all the questions that are showing up here on the live chat. And then, of course, we have YouTube as well, which we'll jump on, and anything on X as well afterwards. Okay, would you be able to explain the difference between a positive EAMT and a negative EAMT? Okay, so you're going to hear about this quite a bit. And basically, this is all about mountain torque and how it impacts your jet stream dynamics. Okay, so when you have a positive EAMT, okay, is basically when you are seeing this dynamic. So basically you get all your convergence on your short waves here, and it just drives a strong trough around Eastern Asia and sets up this powerful jet streak here. Should I say Western Asia? And this powerful jet streak basically over Japan driving into the Pacific. When you see this pattern, you're less likely to get polar air to push into North America, and you end up with generally mild conditions. When you see this, whether or not you're dealing with a torch pattern or not really comes down to just how far this extension gets and how does it interact. So when you have this type of pattern set up and you want to see what impact it has on the East Coast, and I'm sure on the West Coast it's pretty easy to have an impact on your weather pattern, and a wet weather pattern at that. But it's not as direct for the East Coast, which is why you want to be very careful when you start making announcements about torches and whatnot, because in terms of energy and whatnot, it has an impact. So in this scenario, it works to an extent, but you start getting these ridges on the West Coast and around the Rockies, which sets up the storm that we had recently. And it sets up the potential for polar air masses to drop in from Canada. So it has an impact, but it isn't always the dominant impact. Now, when you have this type of pattern in place, then it's very difficult to get your winter storm pattern. I think everyone agrees on that. And no one said it differently. When you have a negative EAMT pattern, you basically get the reverse here. You get a nice ridge over Japan, you get a deep trough around the Aleutians, and you get ridging building up through Canada. And basically what happens is that this whole setup here shifts more from north to south rather than west to east. That's essentially. There's more technical terms, and you could definitely pull that up on the AMS website. But that's basically what you need to know in terms of that pattern. And it's typical of this jet streak here. It typically develops this jet streak here when you have a positive EAMT weather pattern. It's pretty much all of the influences of the mountain torque over Asia and how that all plays out. Now, again, this is what I call a reactive signal rather than a driving signal. Okay, and I personally separate them. Not everyone does this, but a lot of people, they look at all the acronyms that we have and they look at it as drivers, everything. And what I do is I separate. I say, okay, what's actually causing this? That is a driver that I have to study, not all the acronyms. So I don't worry about what the NAO is doing now. What I want to know is why is it doing what it's doing? So this whole evolution was driven by the MJO state. And the MJO state was influenced by what we're seeing in the evolution of the polar vortex and what we're seeing with El Nino. So you add those combinations. Now, some say, hey, look, you don't need to throw in the QBO. It doesn't matter. I disagree, because you cannot look at this weather at the atmosphere in a 2D spectrum. You have to look at this in 4D, okay, 4 dimensions, because each factor is interacting with each other. If you don't think each factor doesn't interact with each other, then you're acting like as if the whole atmosphere is acting only in the segmented volume. You know, this segmented vacuum, should I say, where one doesn't impact the other. It does. Everything impacts the other. So you have to look at everything and how it's all playing out, which is why I said this is short-lived. This is not going to be as robust as what is being forecasted. It won't last as long. It won't reach the East Coast and have as much of an influence as you think it will. Because when you look at what's going on with the atmosphere as a whole, you see all the other factors fighting against it. So that's what we're essentially seeing, and that's what those two patterns are. We are getting ready to shift, and when we do, well, that's when things get interesting. In the location of both 10 millibars and 70 millibars, let me go. I think that's here. Okay. Polar vortices to between Greenland, Russia, and Scandinavia, temporary and just part of the process of warping and weakening. The concern being the stratospheric warming and vortex disruptions occur at the intensity indicated, but the placement is wrong and keeps Asia cold and us warm. The current placement, if we continue to see only warming in Canada, northwestern Canada, in the stratosphere, then pretty much all the cold air would be locked into Eastern Europe and Asia. But that is not what's happening. What's happening is, and let me pull up that data. Let's see here. Okay. Did I delete it? Oh, maybe not. Okay, so what's happening here is that, okay, so we start off here, and if we kept this warming going like this perpetually, then yeah, all your Arctic air and all your polar air basically gets locked up from Asia through Europe. Okay, it gets all locked up into here. But what's happening is we are shifting, there's that warming, away from that idea. And now you're getting the warming here. Very robust warming at that. which translates to this shift. And once this happens, then everything heads towards North America. So that's why we're seeing that change. If we constantly were locked into this and all your warming kept on focusing over Canada, then yeah, absolutely, we would be in some trouble. But, and actually, Dr. Cohen was also mentioning this, that he was concerned about that, hey, if this perpetually sets up in Canada, then that prevents the true Arctic air from invading the United States and North America overall. But when we started seeing this, and now this is only 5 days out, that's a change. That's what's going to shift this pattern and drive that cold air towards us in January and February. When you say concerned by what's coming down the pike, what is the concern? Well, for one, I am concerned about the fact, considering we haven't seen this in about 3 or 4 years, is a wave of winter storms impacting the region. I'm concerned about coastal flooding, very concerned considering what we've been dealing with, and I'm concerned about, with the heavy precipitation, the potential for a lot of damage in terms of flash flooding and snowmelt flooding. This is going to be a very, no matter what happens with the cold air, this is definitely going to be a stormy pattern. So I'm very concerned about the damage that could be lining up here for January and February. If we're dealing with a lot of tropical moisture and we just get a marginal polar air mass, you're talking about a lot of heavy wet snow. Now look, it may not pile up on the record books because everything's 8-to-1 and 10-to-1 in ratios, but you're basically talking about cement-like snow that we haven't seen in several years, impacting travel, impacting the house structures, impacting a lot of factors here. So I'm a bit concerned in that respect by what I'm seeing. I pretty much went over the whole thing. Look, I will explain. Let me put it to you like this, because I'm getting a question about a meteorologist that I ran into. I laid out exactly what I thought was going to happen, and he laid out what he thought was going to happen, and I basically went with the idea that this is a transient pattern. We get polar and Pacific air masses. This isn't going to be a weather pattern where like we're constantly in the 50s, which we haven't been. That's where I'll leave it on that. Given the increase in volcanic activity, yeah, I've been noticing that, including observed activity on the ocean floor, doesn't geothermic activity have to be considered as a factor also when it comes to ocean temperatures? There is that factor, absolutely, but the degree of the warming that we're seeing in the oceans, you would have to have a lot more volcanic activity. But it's certainly a factor, don't get me wrong. Also, less particulate pollution from industry due to cleaning air over the last 70 years, and also more sunlight. Yes, all those are factors, absolutely. So here's the thing. I hear this a lot, and I'm going to play devil's advocate. Yes, those are all factors, but that doesn't negate the CO2 factor. They both matter. So they both are an influence. So I don't know, when I think of climate change factors, I'm just looking at the observations. I'm looking at what we're seeing with the precipitable water values. And yeah, there is a change. There are factors involved in that change, from natural factors, our factors, factors that we may not fully understand, geological factors that we're still studying. In fact, there's even a great paper that just came out about the reduction of volcanic activity from the 1800s to the early 1900s, and how we haven't been as active. So that reduces some of the soot that's in the atmosphere and allows for more warming in that respect. That's certainly an interesting factor, because then you might have to adjust the baseline. But it doesn't negate what's going on. You know what I'm saying? So you have to combine all those factors. So one does not change the other. I'll put it that way. I'm not one to go and say, well, it's only this, or it's only that, or because of this, it negates that. It doesn't work like that. The atmosphere doesn't respond to that. What you put into the atmosphere, you're going to get a reaction back. That's basic physics. So that's where we're at right now. And that's how I'm handling the forecast here. And this is why I also don't try to compare patterns from the 1980s or 1950s till now, because we're dealing with different sea surface temperature anomalies. So and gradients. So you have to acknowledge that in order to forecast properly. Can you say with confidence when our first favorable period for winter storms and snowstorm setups? I could say with confidence early January, but I have no confidence of who gets what. Okay? So I have no idea whether your backyard will get a half an inch of snow or a half a foot of snow. No idea. But early January is looking like a very favorable period for winter storm activity. The reason people are skeptical of climate studies is nonsense like nature just, here's the thing. I can't help what other people do. I have been having an argument with disagreement with other individuals in terms of climate and weather, and saying, like, look, guys, we need to stop advertising the most extreme solution that most likely end up on the Sci-Fi Channel.
Since we were kids.
Right. How many times have I been told that New York City was going to be underwater? It ain't underwater. Yeah, we have coastal flooding. Absolutely. New York City is not underwater. Florida is not underwater. The Antarctic did not all melt. Are there signs of glaciers breaking off and whatnot? Absolutely. But at the same time, I'm really big on technology. So I don't think the world's going to end. But that also doesn't mean that I think that we should be opening up more coal mines either, because that's not good either, So I'm a very realistic, pragmatic person. I can't control what other people do or what, I could put on Fox News and they have some ridiculous nonsense and a guy throwing a snowball on the Senate floor saying nothing's happening. And I got another idiot that's running around thinking that the world's going to turn into Venus. So you got idiots on both sides. What you need to do is just use some common sense. Basic physics. If you add something into the atmosphere, you're going to get something back. Simple as that. It's very, very simple in that respect. What could cause major stratospheric warming not to be as robust as predicted or to even end up being a bust? Okay, so great question. So first of all, because this is 5 days out, I'm a little bit more confident in this feature showing up. But let's just say we get the 5 days out at this time period here. And this is weaker and displaced more to here, towards, let's say, Siberia and Japan. Then that would mean that your displacement would be such that it wouldn't be as strong. It'd be directed towards the west coast, and you basically get all your cold air funneling into the Rockies and the northern plains, and we miss out. Or this warming sets up, but instead of starting to shift this way, that, instead of the 10 days out, instead of it doing this, it instead shifts more to here, then that would suggest that your warming then gets shifted towards Canada, and you miss this whole process, and your cold air gets dumped back into Europe. So those are factors that we're going to have to watch out for. The fact that we've been constantly showing this solution makes me more confident that this is what's going to pan out. But these are the things we're going to be watching over the next several days and weeks to see where it sets up. Looking at the models due to the upper ridge retrograding towards northwest Canada, let me pull that up. Let's see here. Upper ridge towards northwest Canada and Alaska across polar flows seems to be projected to set up that would allow polar, maybe Arctic air to interact with the subtropical jet stream. Yeah, that's basically the idea. There isn't a signal of a robust negative NAO yet. And I wouldn't trust any type of orientation forecast beyond 10 days, let alone 15. So I don't like using that guidance as like, hey, this is definitely going to happen. But what I like seeing here is this shift in this transport. And then once you start getting cold air interacting with the subtropical jet stream, then you start looking into potential and details in that respect. My forecast is 50 in rain in LV. That would be quite the shift. I don't see it. Understandable. I'm not saying it's a slam dunk in any way, shape, or form, but I am very curious to see what evolves here. Because again, we went from initially a storm cutting up through Michigan and just warm air surging everywhere to now we're seeing a backing off of the warm air transport and a low pressure system that is bombing along the mid-Atlantic coast towards New England, but no real cold air getting pulled in till later. It doesn't line up. And what I'm worried about here, what I'm interested in, so to speak, is that if you're having this low pressure system rapidly intensify during this time period, and your upper level low is right back here, there should be some sort of jump here going on. So there's a displacement between what's showing up in the 500 millibar pattern and what's showing up at the surface, and the changes are going on in the model guidance. And then you combine that with this cold air that's aloft under that 500 millibar development. That's why I'm saying keep an eye on this, because I think there is a potential, if you continue to see support for a coastal low along the coast here, that what you end up with is a rapidly deepening 500 millibar low, which as the heights are falling, it cools the atmosphere. And so what you start to end up with is rain that starts to mix over to snow. So your high temperature may be 50, but by the time your heavy precipitation kicks in, you might be falling through the 30s. And there you go. And the only reason why I am bringing that up is that, again, we're seeing this surface low that is now intensifying on the coastal plain here. And when you get this process evolving here, you're going to get falling 500 millibar heights. And when you have that happening, you also get a lot of cooling. So again, this is why I'm kind of focused on the interior of some mischief happening here that we're not seeing. Again, this is more than 5 days out. So that's why it has my attention. I'll put it that way. That way you're not blindsided by it, by saying, hey, a couple days ago it said 50. I don't need to worry about anything. I'm just going to go on a trip, go to Vegas, whatever, because I know some snowplow guys do that around this time of year. But instead, just be aware. I'm not saying put on the snow plows and get ready for a heavy snow event. I'm just saying this has my attention because there's a lot of moving factors, and I'm going to keep an eye on it. You don't have to, but I definitely am. There is certainly a ton of cold air at all levels of the atmosphere right now in Quebec and Eastern Canada. Have a ton of cold air. Yep, north wind drains south. Absolutely. So we're going to have to definitely watch that. Has the warming over Asia at the stratospheric level been observed yet, or is it projected? It's been observed as far as the first wave. The second wave that really sets us up is what's being projected right now. That's 5 days out. The one thing that I will say in this scenario is that because this is 5 days out, I have more confidence in it than, let's say, if it was something that was like 10 or 15 days out. We've been seeing this progression for the past 5 days from the 10-day prog to the 5-day prog, and it's only been getting stronger. Let's just say it's my opinion that there is a better chance of Independence Day happening than the day after tomorrow. Okay, I would say neither. Because quite frankly, I mean, why would aliens visit us? I mean, they'd probably take a look at us and like, nah, no thanks. Will you do a pinstripe bowl forecast for Rutgers versus Miami on afternoon December 28th. I didn't even know that was a thing. I guess I can always pull it up. I will check it out. Let's see. Well, let's see what the data is right now. I see. Right around that time period. I tell you what, once we get closer, definitely card remind me, and I will throw it in there in the sports forecast. Let's see what's going on YouTube land. Well, quite a bit of activity here. Let's get the best question. Do you see any evidence that the potential pattern change has any staying power? Oh, tons. Yes. Well, we already talked about that with the MJO, and that's where some people who are hell-bent on having warm pattern are going to point to. And understandably so, because if the stratospheric warming doesn't work out, that is what's going to happen. The MJO is going to go into phase 3, 4, and 5, and you're going to get a break. I will say this also. I have yet to experience a winter where you have a cold period and then a relaxation and a cold period again. I've seen plenty of winters where it just stays warm, like last year. I've seen plenty of winters where we get a warm start, then we get cold, and then relaxation, and then mid-February to March we get cold again, and just about when everyone's ready to play baseball in April, it gets cold again when you don't want it. So I've seen that. I've seen all sorts of configurations. What I have yet to see personally in the northern mid-Atlantic, New England's a different story, but in the northern mid-Atlantic, where we stay below normal from late December through March. Haven't experienced that yet in my life because we live in a very volatile area of weather and a lot of interaction and very temperate. Okay. That's our general climate. So it's really difficult to pull off persistent below normal temperatures throughout the entire winter. So that's why when I see that, I'm like, well, there's always a relaxation. And when we get that relaxation, I guarantee you people are going to say winter's over. And then they're going to be surprised when it's not. I've made that mistake once in the past where I thought that the pattern was moderating in late February. Then we got that shot in right around the late February into March, and we got that winter storm in March. It caught me by surprise. So it's even happened to me. So I would warn against trusting an early end or anything of that nature. But I also wouldn't go around saying that there's no chance for a moderation at all. I mean, that just doesn't happen. That's not the nature. Weather patterns, when they amplify, at some point they relax. And then they amplify again, depending on forcing mechanisms. But when you have amplification, you eventually are going to have a relaxation. That's just the way that the atmosphere works. Let's see. Let's see. As far as HDDs, let's see here. Okay, so that's basically energy forecasting and temperatures. Any risks to January forecast with this? I would say when it comes to the long range HDD forecasts, stay away from extremes right now. Extreme warmth or cold. Okay, I like slightly below normal. I wouldn't go extremely beyond that. I know some of the guidance is really robust in that respect, but I want to stay away from that because the polar and Arctic air masses that come in. I want to see what that moderation rate is when they come in because we don't have an established snowpack yet over the northern mid-Atlantic. So when they come in, they're more likely to moderate faster. So I always like to stay away from extreme ideas in the long range, whether it's cold or warm. Let's see here. You're welcome, Zaziva, I guess. I don't know. Any chance of snow in Boone, North Carolina, first week of January? Probably not. Now, the rest of January, that might be a different story. But, and my parents are probably ticked off I even would say that. But the first week of That's going to be hard to pull off. Since get very used to very warm temperatures at Jersey Shore, since our winters keep getting warmer each year. I saw some data on that, and some of the data is, well, some of the data was skewed because of just urban heat island effect. So there is that aspect to it. They really didn't do a good job of separating that out. I think one of the interesting forecasts that showed up with climate change and some of the model data that was shown as far as the climate models was a more persistent La Nina potential. Okay, now we already seen a prolonged La Nina event. Why is that important? Well, La Ninas tend to be milder winters for us. They are cold at the start. So if you're looking for a white Christmas, you actually want a La Nina at the very start. But then the rest of the winter is pretty quiet. And that is because of our southeast ridge. So if you get more persistent La Ninas, then you're more likely to get warmer temperatures on average for your winters in the mid-Atlantic. Let's see here. Let's see. A lot of great stuff. I'm trying to pick the best one. Steve, the 12Z Canadian shows your idea on the cooler solution. I didn't get a chance to take a look at the Canadian guidance. Might as well check it out. See if I can pull it up here. Let's see here. CMC. And this, by the way, is weathermodels.com. Pretty great model website. Let's see. We'll look at thickness here. Okay, so there's our evolution. There's our storm. Christmas is quiet. There's our storm evolution. Okay, so it suppresses everything. It has a difficult time. I see what it's trying to do here. So it's taking this low pressure system and now it's just kind of crushing it. I get what it's trying to do. Let me see what it's pulling off here at 500 millibars. Let's see here too. Heights. I guess we could use heights. Okay, so there's our upper level low marching across. And there, oh wow. Okay, so this went from one extreme to the other. So this one went dropping the upper level low down towards the Gulf Coast and then out. So it suppresses everything. This might be a little bit too extreme as well on the other extreme, on the other side. So it's certainly some very interesting data nonetheless. Something definitely to keep an eye on. This might be a little bit too much. I think this is really knocks it down south. So maybe, you kind of split the difference here. And so instead of the European, which is, let me go up here, which is up here, and this is down here, maybe it takes it through the mid-Mississippi River Valley. And then instead of it down here, let's say it's up towards the Tennessee River Valley and it shoots out this way. Whereas the Canadian really suppresses it down towards Georgia. What we might end up with is more like towards North Carolina and Virginia. Kind of splitting the difference between what the European doing, what the GFS is doing, and what the Canadian's doing. But again, this is kind of my point where we need to kind of watch this. This is not in any way, shape, or form closed off in terms of what we're going to be dealing with. Do you think future winters will look like along the Jersey Shore? I mean, I can't say snowless. It's funny because when we had all those winter storms in 2009-10, the first thing they did was blame it on climate change. So it depends on a lot of variety of factors because you have to add some things here. Okay, so you end up with a warmer climate, but we're still in a temperate zone, which means you can still pull in polar and Arctic air masses towards our neck of the woods. They may not be as strong in the future, but it's still cold enough. You don't need it to be 20 degrees for it to snow. So you get marginal air masses and a ton of moisture, and you can end up with some very impressive winters. On the other hand, if you get a persistent La Nina setup, then you can end up with a lot of winters with a lot of disappointing snow lovers out there. So I don't think it's like a slam dunk either way. I think that's an error. That could really catch you by surprise. Give me the Pacific jet stream. Still looks extremely strong. Almost reminds me of last year. Still doesn't look like the part will change much the next 10 days to 2 weeks. I really think this pattern change. I would have to disagree with you. Based on what I'm seeing right now. I'm sorry, but the jet stream is what you would expect with the MJO Phase 5. There's nothing unusual or strong about it. And all the other forcing mechanisms, in order to believe that the jet stream is not going to change in the Pacific, then you have to believe that there is a separation between that jet stream and all the other forcing mechanisms. So which is it? Is it the forcing mechanisms that cause the jet stream, or is the jet stream just out there like a boogeyman and just it won't go away? I'm going with the forcing mechanisms because, that's physics, right? So we're seeing all these changes with the MJO and whatnot. The MJO actually has been modeled very, very well. And all the factors we have been seeing, if you stay within that 5 to 10 day window, if you go out to that 15-day window, that's going to be an error. And that's where you're focusing on, where the 15-day MJO for December 20th was a phase 8 because it went into neutral. But if you stay within that 5 to 10 box, it's actually forecasted and verified very well. And that's what you really want to do, because the MJO that far out is very, very volatile. Are we expecting a mild Christmas Eve and Christmas Day without rain? Oh, absolutely. That's been the forecast for literally weeks and months. Do you believe that Ninos have a big say even if they aren't strong? El Ninos and La Ninas and neutral, they all have a factor. They all have an influence. The question is, with each year, is to what degree? If you go out there and just say strong El Nino and just slap out a forecast and that's it, you're missing a ton of other forcing mechanisms. So that's why you can't just go with that. Let's see. Now we're going back here to... honey, is there any questions out there on X?
I thought you'd never ask.
Oh, geez. All right.
Right there. Give me a second.
It's already 9:02. I'm going to be definitely going over.
Yep.
Oh, well. It's that time of year. That's why I got the water.
Yep.
So I'm going to answer this question or these questions, and then I'm going to handle the rest on the live chat, and then I'm going to relax.
You
So-
have to scroll through all that.
Holy Christ. Wow, it got busy. All right, let's see what we got.
Take a look, man.
All right, let me take a look here. Let's see what we got here. Models seemed... okay, so I think I already answered that with the
you might have already
HCE.
addressed some of it.
Liquid depth, fantastic water. Indeed. You know what I love about this is that it stays cold perpetually. And I want to thank my wife for introducing me to this. I absolutely love it. Keeps my voice too. So you're saying we don't really need a 1.8 MJO if other long wave factors are
You
dominant?
gotta hold it, otherwise it's just gonna disappear.
Okay, that's a great question. Okay, so 8.1 is optimal. Okay, so let me put it this way. 8.1 is 10 out of 10 optimal, excellent weather pattern for tropical forcing. 8.12, I put an 8.12. Okay, I see that has my attention. Keep an eye out. Neutral in a robust El Nino or La Nina tells me that the MJO wave isn't a factor, the MJO influence, but that doesn't negate tropical forcing depending on what you're seeing with your El Nino or La Nina. So, for example, if I had a neutral state and I had an El Nino, but all the convection was down by, let's say, Hawaii, and it was east base and everything was focused towards Mexico, then that would tell me that we have a weather pattern where the subtropical jet stream is plowing through California and keeping us very mild. If I had an El Nino with a neutral MJO and all my convection was focused towards the dateline, that would tell me that more than likely I'm going to have more cyclogenesis on the East Coast. We're going to get a subtropical jet stream through the Gulf of Mexico and the Southeast, and we have to be on guard. You have to combine that, though, okay, with what's going on in the polar jet stream and all of the forcing mechanisms on your high latitude blocking. So, again, this isn't just like pick one thing and then roll with it. You have to look at all these different factors and combine all of them together. And that's generally how you have to look at the pattern. You can't just say, okay, pick up this and that and then leave it alone. You have to look at all the factors and what's going on in the atmosphere at that time. No weather pattern from years before is exactly the same, or even in some cases nowhere near the same as the pattern you're dealing with right now. So you have to be aware and look at all of the factors and all of the features going on and what is changing in the atmosphere. There it is. Okay. What's the average lag time for the MJO phases and force and continuous forcing? That kind of depends on what's going on in the atmosphere, but I like to give it about a 3 to 5 day lag. That usually works out for me. It's not always locked in, but that usually works out for me. More people globally. Well, that's definitely true. Just look at Elon Musk. That guy's having tons of kids. 10 to 15 days, Steve. Also, the lakes will be in play due to lack of ice cover. Oh, would lake effect snow? Oh, definitely. Oh, absolutely. Yep. We want snow. I know. Believe me, I know. I've gotten emails. I will be okay without snow. Okay, so the guy who's okay without snow should duke it out with the guy who wants snow and then leave me out of it.
No.
Okay, so I think that's all of the
You got more
NX.
going on YouTube.
Let's see here. All right, let's see. What else we have here? Wow. We have a ton. It's at Yankee Stadium. Okay, yeah, right. With the current El Nino being strong but acting like weak to moderate with the MEI and ONI, what are the best tools to analyze the El Nino to determine the effects on weather in the Northeast? Keep an eye on where the convection sets up. Where are your thunderstorms setting up? They're setting up around 180 longitude. That is a sign that your forcing mechanisms are going to be such that you're going to see more storms along the East Coast. And that's what we've been seeing, by the way, where our low pressure systems are more likely to develop on the coastal plain. So there's something there. Hello, Robert. How you doing? I remember one year we got our first storm in mid-January. It was warm for a couple of days before the storm. It got really cold a day or two prior, and then we got hit with a big storm, and then it kept going. Also a reminder that the backroad winter of 77, 78 can be very busy in a hurry. Oh, absolutely. Oh, that is definitely true. Compare Long Beach Island now compared to 4 years ago as far as stuff built there. Oh, absolutely. Yep, that's certainly a factor. Let's see. I see some people are saying mild and not much happening till second week of January. Do you disagree or agree? I think we already went over that pretty well, so I'm going to leave that alone. Why does it seem like there are more La Ninas versus El Ninos? That's a great question, and there is a lot of research going in on that, and some factors, maybe again because of that whole climate change factor and how the winds are reacting and the pressures in the Pacific are setting up more La Nina favorable environments than El Nino favorable environments. So that could certainly be a factor. Because if oceans are truly warming and climate change is really driving things, wouldn't there be more Ninos than Ninas? No. And I'll tell you why. Because of the changes in the thermal gradients with the ocean, especially with your PDO factor, it sets up a more favorable environment for your La Ninas to develop, which then leads to colder water. I know it sounds contradictory, but it actually makes a lot of sense because the atmosphere is trying to balance out all this warming. So it sets up a cooling phase, all right, as a reaction. And so that's why we see what we're seeing. Statistically speaking, around New York City, when December sees little or no snow, the odds of a below normal snowfall are around 70%. The odds of an above average snowfall are 20 to 30%. Do you believe the 20 to 30% will win out this winter? Well, I mean, geez, it's kind of like the same question over again. But all right, so here's the thing. That statistic is very misleading because you only need about 4 inches of snow in New York City to be above average. And so a lot of those 70 to 80% verifications either happened the first week of December or the last week of December. And there was a lot of mixed data in between. Again, the problem with using statistics from years past is that we're not dealing with the same type of environment. And so I would caution against trusting that analysis. Now, with that said, if you had a very quiet December and you're in La Nina, yeah, you're definitely going to have a below normal. If you're El Nino, then you could possibly be in that 20 to 30% ballpark. Why? Because El Ninos typically are backloaded winters. So I'd be careful with that statistic. You have to look and dive into the details of what caused those and then separate that out between El Nino and La Nina and neutral. And then also what happens when you have an El Nino and a negative QBO. What does that statistic look like then? Rather than just taking that ballpark statistic, because in the atmospheric science, there are so many factors that go into that you might have a majority of those factors that cause it 70 to 80% not even being valid in this current weather pattern. New GFS extended is looking nice through January 15th. But after it goes back to a trough on the west coast in Alaska. Is that incorrect? I don't know. I didn't look at it. I mean, the new GFS, let's see, is it the 18Z? Because you guys know my point of view on the 18Z GFS guidance. So let's pull it up. Let's say North America, 500 millibar heights. Well, I don't really see much of a trough in this. That's a nice ridge axis right there. You have a trough, broad trough over the east. You got some sort of ridge axis trying to take shape here over Greenland. So I don't really see this as being a trough over the west coast. This right here, possibly not as robust, and so maybe you get more of a Pacific air mass setting up here. Again, this would line up pretty nicely with the idea on the GFS ensembles of the stratospheric warming not being as robust. They go out 840 hours. Oh, those. Yeah, all right. First of all, again, much like the European weeklies, I do not trust anything at 840 hours out, much less anything else that far out. So it depends on what the forcing mechanisms are behind that. I don't think I have that data, though, available to me right at the moment. I could probably find it. But I'm going to check out to see what we got here. See what else we have here. I'm going to be shutting down in a moment, but I want to see if there's any good questions here left. Oh, any idea what causes split in models? three things: data that goes in, resolution, and physics in the model guidance. Those three things. This is why the European is kicking the GFS's butt almost every week and month and season and year and decade. So that's why. I wish the GFS, look, if I ran for president, the first thing I would do is fix the GFS by buying the European and just calling it the GFS. That's all. I don't know what to tell you. It's been a bane, and I don't know why. I wish it would get better. But I think that's it for tonight because I'm starting to lose my voice. So, a couple of things before we close up. I will be going on my Christmas vacation, which not really. I'm still going to be here doing the forecasting. But most likely, unless I see a significant change in the forecast for the storm next week, and that'll be around Wednesday. Right now, tentatively, no live chat next week. But if the storm is more robust, then I will do a live chat because it needs to be covered, obviously, and take care of everything. But for now, the going idea is that, I normally take a little bit of a break for the end of the year just so I could recharge for January and February and get going because, again, normally I'm the one doing the 24-hour snowfall forecast and whatnot. But I will be around, obviously, and if these storms, if that shift east is more robust and we have more snowfall to talk about, I definitely will be here. But for right now, it looks like I'm going to be taking that week off and enjoying myself with a ton of Christmas cookies and a whole lot of fun. So I want to wish everyone here a happy holidays. I know we had Hanukkah, so happy Hanukkah, a happy Merry Christmas, Merry and happy everything else that you might be studying, Kwanzaa, whatever, okay? And Happy New Year, of course. And I'm looking forward to seeing you guys all in 2024. I got some things I'm going to be upgrading around here as well. And if we get a storm setting up between now and the end of the year, I'll send out the emails and we'll have this live chat right here and talk about it. That's it for tonight. Before I lose my voice, have a wonderful night. And as always, stay safe out there.